All right, here we go with our second video. I'm still working on our only standard for this unit, which is to determine the solution set of rational equations and inequalities, and we're going to be working with multiplying and dividing. So we haven't even gotten close to solving because we have to know how to work with adding, subtracting, multiplying, dividing, and reducing our answers before we can get into solving. If you want to relate that back to when you first learned how to solve equations, you had to know how to add and subtract, multiply and divide numbers before you were able to solve them. So all of these skills that we're learning are actually preparing us to be good at solving, which is our goal. Let's go ahead and get started. So here I've got two examples for multiplying. And I would like you to consider that when you're multiplying two fractions, it is simply a matter of multiplying the numerators and multiplying the denominators. And once you do that, then you're in a position to reduce. However, you may also consider this just a giant factor, which means, according to our last video and the last lesson, that you can actually reduce anything on the numerator with anything on the denominator so long as it is a factor. That is, that there's no addition or subtraction that holds it onto something else. So right now, since it's all multiplication, I can just start reducing. So I'm going to actually do this in two ways. The first way is that I'm going to multiply the numerator and get 54y squared. And then multiply the denominator and get 72y to the fifth. And now with this, I would have to grab a calculator and reduce the 54 over 72 and the y squared over y to the fifth. Okay, so that's fine. So if I were to reduce the 54 over the 72, and I want this in a fraction form, I would get 3/4. Okay, and then if I were to reduce the y's, I notice that I have 2 y's in the numerator and 5 of them in the denominator, which means that I'm left with 3 in the denominator because we use subtraction. So this would be my answer if I chose to multiply the numerator, multiply the denominator, and then reduce. The second way would be, I'm going to rewrite it real quick, would be to do any sort of reducing that you see that catches your eye right away. So I see that 27 and 9 can be reduced. I'm not canceling them, and there's no addition or subtraction, so this is completely appropriate. So this reduces to a 3, and then I see the 2 and the 8 reduces to a 4. So I have reduced my numbers down to 3/4. I also see that the y squared and the y to the fifth will reduce to a y cubed. So either way I get the same thing. It's just whether or not you want to make larger numbers and then reduce them, or reduce the smaller ones that you see. Completely up to you. In the next example, I'm going to have to factor, because the only way to cancel or reduce is to factor. You may not just reduce this 8 and the 4 and the 2 and the 4. You cannot do it because they're attached to an expression with an addition or a subtraction sign. Excuse me. I apologize about that message. Alright, so here we go. I'm going to factor this by multiplying and getting a negative 24m squared. And this is going to say, let's see, how about 6 times 4? So I can do a negative 6m and a positive 4m. So I have 3m squared minus 6m plus 4m minus 8. And I'm going to factor that by grouping. So 3m, and I have m minus 2, and then over here I'm going to take out a 4, and I have m minus 2. So I'm not done factoring yet because I have m minus 2 times 3m plus 4. So that's the factor by grouping method. And in the denominator here, I'm going to factor that using the different squares. So I have 3m minus 2 and 3m plus 2. In the other one, it doesn't seem, oops, that's multiplication. In the other one, it doesn't seem that anything can be factored. I have no GCFs. I don't have any quadratics because nothing is squared. So I'm left with just leaving those as is. And now I'm going to treat this as one large fraction bar where anything in the numerator can get canceled or reduced with anything in the denominator so long as the entire factor is exactly the same. So my 3m plus 2 and 3m plus 2, and my 3m plus 4 and 3m plus 4 will reduce, leaving me m minus 2 over 3m minus 2. This is actually the simplest form of this expression because I cannot reduce those 2's. They are part of the quantity. Imagine that being 5 minus 2 and 6 minus 2. You cannot just cancel the 2's. You would have to use the numerator and use the denominator. This is a grouping, and you may not cancel across it. Those of you that understand my point are over me saying you cannot cancel it, and those of you that are still interested in canceling it, you need to hear me say it another 100 times. So I'm going to keep saying it. All right, now we're going to do dividing. And the reason I only gave us one division problem is because division is actually multiplication. We just have to multiply by the reciprocal. So in my factoring, I'm also going to flip the second one because that's the one I need the reciprocal of, which just means to flip the fraction. So once again, I'm going to multiply this and get I'm going to get 12m p, they're p's now, p squared, which will, let's say I can use 4p and a negative 3p. So 3p squared plus 4p minus 3p minus 4. And if I factor out a p, I will have 3p plus 4. And here I have to factor out a negative 1. And that leaves me with 3p plus 4. It's important that you take out the negatives so that these signs match within the parentheses. So the new factored form of this piece right here is 3p plus 4 and p minus 1. In the denominator of that piece, I'm going to factor out a GCF, and that GCF is 8p squared. 8p squared, leaving behind not just a 3p, but I have to consider that if I took out everything from here, that there's a placeholder of a minus 1. In the next one, the next fraction, I'm going to flip it over. So that is that this is going to become the numerator, and I'm going to factor it. So when I factor that, I'm going to take out probably a 4p. That looks like the largest thing. Maybe I can take, I can take a 12p out of there, leaving behind 2p minus 3. Okay? And in this last piece, which is now going to become the denominator, I'm going to factor out a 9, leaving me a p plus 4. So I need to scan this and see if there's anything that I'm able to reduce. Remember, I'm not canceling stuff and just slashing it off of the screen. I am going to try to reduce everything. And I don't see anything that's in parentheses that's able to be reduced, but I do see that I have a 12p, an 8p squared, and a 9. So that's the parts I'm going to reduce now. That is that the p's are going to reduce to just a single p in the denominator, and that the 12 and the 8 can reduce. So if I divide them both by 4, I get a 3 and a 2. And this 3 and the 9 can now reduce, leaving a 3 and a 1. And the 1 is not necessary unless it was the only thing. So my numerator is not actually very pretty. It's 3p plus 4, a p minus 1, and a 2p minus 3. And my denominator has a 6p that comes from all of this, and then the factors of 3p minus 1 and p plus 4. Since none of those factors are identical, nothing else can be done to reduce this. Okay, so this was a very large problem that involved a bunch of factoring and actually very little reducing. All right, this last example, I've called it a challenge, but really it's just a combination because I have multiple expressions here, and I have multiplication and division. So call it a challenge or call it a combo. It doesn't matter. We're going to give it a shot. So again, the first thing we have to do is factor everything, and then whenever we see division, we remember that we want to use the reciprocal. So I'm going to rewrite it. I'm going to write this as 3, and then this x minus 2 squared, I'm going to write as x minus 2 times x minus 2. Don't multiply it out because that's actually going in the wrong direction. We want everything to be factored here. In the denominator of this fraction, I'm going to go ahead and factor that to x plus 6 and x minus 1. In the next fraction, I see a GCF between 4x squared and plus 24x, and I see that to be a 4x as the GCF, leaving behind an x plus 6. In the denominator, I see the difference of perfect squares, so x minus 2 and x plus 2. And in this last one, technically this is a fraction, it's over 1. So when you write the reciprocal, the 1 is in the numerator, and the denominator has a GCF of 2 times x plus 5. So let's go ahead then and consider all things. I'm going to grab a different color so you can see where I'm reducing things. Remember, this is not one large fraction bar, and anything that is identical in the numerator as it is in the denominator, and that it's a factor, it's not just part of a factor, like a plus 2 or something cannot be canceled. You must cancel the entire factor. We can go ahead and try that. So I see an x minus 2 with an x minus 2, an x plus 6 with an x plus 6. I don't see any of my other factors in parentheses being able to be reduced because x minus 2 and x plus 2 are different. And I also see that I have a 4 and a 2 that I could reduce and just make that a 2. So if I collect everything in the numerator, I have 3 times 2 times x, which is 6x, and I have this x minus 2 times 1, doesn't change anything. And the denominator, I actually have 3 pieces that I must include: x minus 1, x plus 2, and x plus 5. So this is the reduced and most simple form of that giant expression, that multiplication and division problem. And that's it.